Here we have limit x tends to 1, x sinus x minus greatest integer function of x by x minus 1. Okay, to understand this limit, first let's try to understand the graph of this function. Okay, x minus greatest integer function of x. What does that mean? This is a very periodic function, right? When x is between 0 and 1, what will this mean? X minus, this is 0. X minus 0, right? So then between, it will be like this. 0 and 1, it is x. Then again, x is between 1 and 2. Right, 1 and 2, then it is x minus 1. That is like this. Like this. Sorry, it's the same graph. Same graph, it repeats itself. 1 and 2, then 2 and 3, and then 3 and 4, whatever. So basically the graph will grow between 0 and 1. So for example, x is 3.5, then 3.5 minus 3, which is 0.5. Similarly, when x is 2.5, 2.5 minus 2, which is again 0.5. 1.5 is also same thing. 0.5 is also same thing. So basically this graph repeats itself, right, between 0 and 1 after every 1 unit. This graph, these are set of parallel lines. Right, that is x minus greatest integer function of x. Naturally, what does that mean? Sine of this. Sine of this is between 0 and 1, right? This is between 0 and 1. So naturally, sine of this will repeat between sine 0 and sine 1. Sine 0 and 1. What is 1? This is in terms of radians, right? Sine 0 is 0 and sine 1. So what is 1 radian? 1 radian is roughly 57 degrees. So we can say it is roughly between sine function between 0 and whatever sine 57 degrees, roughly 0.8. Okay, so it is, this graph actually repeats itself like this. Okay, let us look at this graph also. Okay, so x minus absolute value of x, these are straight lines. These are straight lines. Okay, that will repeat itself after every 1 unit. Now sine of x minus absolute value of x. You can see this is our regular sine curve. Right. When x is lying between 0 and 1, x is lying between 0 and 1, sine of x minus absolute value of x is equal to sine of x. Right, because this part will become 0. So that's why this graph is coinciding with sine x. Sine x graph. Okay. Now, when x is between 1 and 2 also, when x is between 1 and 2, then also it's the same graph. Right. So that's why sine of x minus absolute value of x is this one. All these parts, it will repeat itself, right? Please understand, it will repeat itself, because when x is between 1 and 2, then also it is equal to sine x. Sine x when x is between 0 and 1. So only this part will be repeated again and again, because x minus absolute value of x, it is not changing. It is always lying between 0 and 1. Basically, this part is always between sine of 0 to 1, which is in terms of radians. Sine of 0 to 1 is this part of sine curve, this part of our sine curve. Right, this is roughly equal to some 0.8. Okay, this point is 0.8 and this point is some 1. Okay, the highest point is 1 and this is some 0.8. Okay, so now the numerator is actually repeating itself. What is the numerator? Numerator is this graph. What are all these graphs? Now the denominator, what is x minus 1? Denominator is continuous. Now if you try to see, we are approaching from the left. Approaching from the left. Approaching from the left, then if you look at this part only, sine of x minus absolute value of, greatest integer function of x by x minus 1, this is equal to, x is somewhere here and this is somewhere here. So x minus 1 is closing to 0, and the sine of x minus 1 into x is close to 1, right? 1 into this one, this is somewhere here, then numerator is somewhere 0, numerator is somewhere around 0.8, right, and denominator is around 0 roughly. So here when you are approaching from the left hand side, left hand limit is some infinity, plus infinity, because what is the numerator? Numerator is sine 1 into sine 1 roughly. So 1 into roughly 0.8, which is 0.8 by 0, which is 1. But when you are approaching from the right hand side, that is right hand limit, then what is this? Then that is about this point. This point is x is approaching 1, right? Then x minus x is approaching 1. This is roughly from the right hand side. X is what? X is roughly 1.00001 something. X minus absolute value of x, that is sine 000 something, by again x minus 1, that is 0.000 something. Basically, this is equal to sine theta by theta when theta plus is approaching 0. Right, basically sine theta by theta, that means this graph, this one, this sine, when theta is very small, sine theta by theta, this approaches 1. Right, but okay, that's what we are seeing here. This numerator is also very close to 0, and the denominator x minus 1, this is also very close to 0. If you draw the graph of sine theta by theta, then that graph, this limit approaches 1. Right hand limit is approaching 1. Left hand limit is ratio of this and this. Right, ratio of 0.8 and 0. Whereas right hand limit is ratio of 0.0001 by 0.0001, which are very two small numbers. Right, sine theta by theta, when theta is very small. Right, and then sine theta is roughly approaches theta. So right hand limit is approaching 1, left hand limit is approaching plus infinity. So the limit doesn't exist in this case. Right, guys. Hope you understood this. The trick here to understand, it is important for us to understand the graphical interpretation of this. X minus absolute value of x, this repeats itself. This is a set of straight lines, right? From 0 to 1, 0 to 1 set of straight lines. Obviously, sine of 0 to 1, sine from sine 0 to sine 1, that is sine 1 is roughly 57 degrees. So this graph will also repeat itself whenever x crosses, it repeats itself between every two set of integers. Right. Now, this one, if you see, now we have this graph, the set of blue lines, and whenever there is an integer, before integer the behavior is different, and after integer the behavior is different. Before integer, this ratio is roughly equal to this number by some number very close to 0. But after integer, this is equal to, this ratio equal to very small number by very small number. So after integer, the ratio is becoming 1, right, tending to 1. Before integer, the ratio is becoming infinity. Ratio is tending to infinity. So left hand limit, right hand limit, they don't match. That's why this limit doesn't exist. Right, guys. Thank you.